In this lesson, we're going to look at combustion reactions, specifically combustion reactions that involve compounds containing carbon and hydrogen. So starting with complete combustion. So this is when a hydrocarbon reacts with an excess of oxygen gas. And that's the key. That's what makes it complete combustion, is that there's an excess of oxygen gas. And when there's an excess of oxygen gas, the combustion forms carbon dioxide and water as the products. So this is the generic equation. So you've got your hydrocarbon reacting with oxygen gas to create carbon dioxide and water. So those will always be the products. So whenever you have a combustion reaction, you take whatever it is you're combusting, you add oxygen, it creates carbon dioxide and water. So you need to remember those three things, and then it just comes down to balancing the equation. So here's an example, the complete combustion of methane. So methane is CH4, so plus oxygen makes carbon dioxide and water, and it's balanced by putting a 2 in front of the oxygen and a 2 in front of the water. Compounds that contain carbon, hydrogen, and oxygen also undergo this same reaction. They still react with oxygen gas to create carbon dioxide and water. So let's look at another example. So we want to write the balanced chemical equation for the complete combustion of hexane, which is C6H14. So we start with our hexane, the thing that we want to combust. We add oxygen gas, which creates carbon dioxide and water. Then we need to balance. So we'll balance this one with a reactant product chart. So we've got carbon atoms, hydrogen atoms, and oxygen atoms. So on the reactant side, we've got 6 carbon, 14 hydrogen, 2 oxygen. On the product side, we have 1 carbon, 2 hydrogen, and 3 oxygen. So when you're balancing combustion reactions, you want to leave the oxygen for last. So we'll start by balancing the carbon. So we've got 6 on the reactant side. We need 6 on the product side. So we put a 6 in front of carbon dioxide. We now have our 6 carbons. Next, we'll balance the hydrogens. We'll just do a little update to the table with our oxygens. So now we have 13 oxygens on our product side. So now we balance the hydrogens. So we have 14 on the reactant side. So in order to have 14 on the product side, we're going to put a 7 in front of water. So we now have 14 hydrogens on both sides. Now we'll update our oxygens. So we now have 19 oxygens, 12 from the carbon dioxide and 7 from water. So when you're balancing combustion reactions, this is where you can use that method of using a fraction, right? We need 19 oxygen atoms, 19 being an odd number. So we're going to use a fraction. We're going to put in front of O2 19 over 2. So if we had 19 halves of O2, so half of O2 is just a single O, so we have 19 O's. Okay, so we're balanced, but we can't leave the fraction like that, so we're going to multiply everything by 2. So that gives us our final balanced equation of 2C6H14 plus 19 oxygen creates 12 carbon dioxide and 14 water. If you are uncomfortable with the fraction issue and you get to this point where you've got an odd number of oxygens, what you can do is just put a 2 in front of your hydrocarbon and balance it again. So start again with that 2 in front of your hydrocarbon.